Okay, and welcome back. So, from last time when we were doing this stuff, we had the monetary authority maximizing their expected utility with respect to inflation. We do it with respect to inflation and not output because the monetary authority can't control output. However, they can in this model control inflation. So, the idea is they maximize their utility with respect to inflation. They want to know what the optimal inflation rate is. So we take the derivative of their utility function, right? We take the derivative of this with respect to inflation, which gives me lambda times alpha minus pi equals 0. When we add pi to both sides, I just get the optimal inflation rate being equal to lambda times alpha. All right, so let's think about what this means in a more intuitive sense before we go any further with the model. All right, what does this mean? Well, what it means, remember, right, alpha was how much inflation deviations from expected inflation affected changes to the growth rate of output. Right? Another way to think of it is how much a signal extraction problem affects output when it comes to inflation. Right? So in this case, what it's saying is the slope of the Phillips curve for output is ultimately a result of how sensitive the public is, or how sensitive the overall macroeconomy is to deviations of actual inflation from what they expected inflation to be, right? The more of a signal extraction problem there is, the higher alpha is going to get, right? So if they're more responsive, right, if they're more sensitive, if they're more responsive to changes in inflation from what they expected inflation to be, right, actual minus expected inflation, if they're more sensitive, or if they're more responsive to that, you're going to see more of a change in output as a result of this deviation of actual inflation from expected inflation, right? Let's talk about what lambda was again, right? Well, what was lambda? Well, if you remember, right, lambda is mistake. How much the central bank cared about output relative to inflation. Think of it as like an elasticity of substitution between output and inflation, right? Because the central bank faces this trade-off between output and inflation. They want higher output according to their objective function, right? If they want higher output, they're going to have higher inflation if they want to cause higher output. There could be other shocks to output that aren't driven by the central bank. That's what that epsilon t was in this Phillips curve for output, right? But if the central bank wants to impact output via their own policies, they can only do so through inflation. Lambda tells me how much they care about that. how much do they care about output relative to inflation? If lambda is large, right? If lambda goes up, right, that means the central bank cares more about output than inflation, right? So how could we sort of take that into consideration? Well, you could think about it as if lambda is large, right, they care more about output than they do inflation. So if they don't care about inflation as much, they care about output more. That has to put them in inflation dove territory, right? They're dovish on inflation. However, if lambda is small, right, they value variations or deviations in inflation much more than they do output, at least via their policy. That puts them in more hawkish territory. So if lambda is big, they're dovish. If lambda is small, they're hawkish, right? So what this tells me is the optimal rate of inflation the optimal rate of inflation is a function of alpha and lambda. Alpha is how easily the public will be responding to inflation deviations from their expectations, and how hawkish or dovish the central bank is on inflation, which is lambda. Right? So how easily they respond to inflation deviations is alpha. How much the central bank cares about the relationship between output and unemployment is lambda. So when you multiply those two together, they are interacting, right? So these two guys are interacting with one another, and that will determine what the optimal rate of inflation is, right? So let's say that alpha is equal to 2, and lambda is equal to, let's make them a little dovish. So we'll make it equal to 1. And you'll see what I mean by dovish in just a second. All right, so alpha's 2, lambda's 1. In this case, the optimal inflation rate is lambda times alpha, which is 1 times 2, equals 2%. All right, so the optimal rate of inflation here would be 2%. All right, but let's assume for a second, we'll do another example. Now let's assume in this example that, let's say, alpha is going to be 2 still. All right, so that part's not going to change. All right, but let's make them a little hawkish. Let's make the central bank a little bit more hawkish. So let lambda be equal to 1/4. All right, well, if lambda is equal to 1/4, alpha is equal to 2. Now, multiply 1/4 by 2, I get 2 over 4, which comes out to 0.5%. Right? So in this case, alpha is 0.5%, 0.5%, or not alpha, sorry, inflation is 0.5% relative to here where inflation was 2%. Right? So if lambda gets smaller, as you can see, the inflation rate drops. And the inflation rate is dropping because they become more concerned with stabilizing inflation than they do trying to increase output above its natural rate. So what are the cutoffs? Right, how do I know where, say, the central bank is more dovish? How do I know where they're more hawkish? Well, if lambda is less than 1/2, they're hawkish on inflation. If it's larger than 1/2, they're dovish on inflation. How do I know? How do I know that, right? Why is that? Well, if you remember, central banks utility was this. So if lambda is larger than 1/2, they're dovish. If lambda is less than 1/2, they're hawkish, because lambda is telling me how much they care about this deviation here relative to inflation. If they care more about inflation than they do this, lambda will be less than 1/2. So instead of changing lambda here, let's instead change alpha. Right? Because remember, like I said, alpha was how responsive the public was to deviations in inflation from what their previous expectations were. Right, so alpha was 2 before. Let's let alpha be 1/2. Right, well, as we can see, okay, let's have lambda be equal to 2. Right, just so we can be fairly consistent with this first example. Right, so instead of changing lambda like I did here, we're going to change alpha. Alpha is going to be smaller. If alpha is smaller, the economy is going to be less responsive to changes in inflation from the expectation of inflation. Therefore, it's not going to impact this as much. What do I mean by that? Well, let's see. First off, the optimal rate of inflation, lambda times alpha, lambda times alpha, mixing these up here. Lambda is 2, alpha is 1/2. The optimal rate of inflation is 1%. Right? Now, let's look back to what the Phillips curve for output was. This is what we had. Monetary policy enters through the way they can shape expectations and the way they can actually influence or use policy to try to influence the economy. Anything else shows up through this epsilon t. Any other change to output that is not a change in inflation will be showing up through this term here. Right? So here I've got output being equal to the natural rate plus how monetary policy impacts output plus other sources of shocks. Right? So if alpha is small, then inflation deviations from expectations won't affect output as much. If alpha is small, the central bank's not going to use as much inflation to try to increase output above its natural rate, simply because they understand that they will not be able to increase output much above the natural rate via monetary policy, via changes in inflation. Right? So they won't do it as much, therefore the optimal rate of inflation will be smaller. Right? Because if alpha is 1/2, all right, let's look at this like that. If alpha is 1/2, right? Any change here, let's say there's just a 1 percentage point difference here. Well, then it just cuts that in half. Any change, any deviation of inflation from the expectation literally gets cut in half, thereby not impacting output as much. But let's, on the other hand, assume that alpha was 2, like what I said before. The economy was pretty responsive, right? Any change in inflation from the expectation of inflation will literally double what this change is when it comes to changing the rate of output. So the central bank takes into consideration what this coefficient is here when they're setting inflation, right? That's part of what they consider. So that explains where these deviations of inflation from expected inflation, right? How one, that can influence actual output, or the rate of output above its natural rate, and also why the monetary authority is choosing things the way that they are, why they are selecting their optimal rate of inflation to be equal to lambda times alpha, because it's a combination of how sensitive the economy is to changes in inflation from expectations and how hawkish or dovish the central bank is on inflation. So that will wrap up this part of the lecture. I just wanted to get some of the intuition and explain exactly what these coefficients meant when it came to why the central bank is optimizing the way that they are. So that wraps up this inflation. It runs just shy of like 20 minutes, I think, maybe a little over 20 minutes. It's within epsilon of 20 minutes, where epsilon is some number arbitrarily small but larger than 1. Anyways, the next one will talk about the actual game theory of the model, right? So changes in expectations, the way the central bank can manage expectations, and the expectational structure in the economy, whether we're looking at adaptive or rational expectations. So be on the lookout. That will be coming shortly. Thanks.